Have you ever wondered how apps keep your data secure while you're logged in? Today we'll demystify JSON Web Tokens, or JWTs, and how they help to secure access to information. Hi, my name is Alex. I'm a senior software engineer with years of experience in API development. My goal is to help you become a more skilled and proficient developer. Let's get started. What is JWT? JWT stands for JSON Web Token. It's a compact and self-contained way to transmit information securely. This information can be verified and trusted because it is digitally signed. JWTs can be signed using secret with the HMAC algorithm or public-private key pair using RSA or ECDSA. Here are some scenarios where JSON Web Tokens are useful. Authorization. JSON Web Tokens are used for authorization, not authentication. Authentication is done by a user providing their credentials to an authentication server, also known as Identity Provider or IDP. After login, users include their JWT in subsequent requests to access authorized routes, services, or resources. Information exchange. JSON Web Tokens are a good way of securely transmitting information between parties. Because JWTs can be signed, for example using public-private key pairs, you can be sure the senders are who they say they are. Additionally, as the signature is calculated using the header and the payload, you can also verify that the content hasn't been tampered with. In its compact form, JSON Web Tokens consist of three parts separated by dots, which are header, payload, and signature. Let's break down the different parts. The header usually consists of two parts: the type of the token, which is JWT, and the signing algorithm being used, such as HMAC, SHA-256, or RSA. This particular header tells us that the token is JWT type and encoded with a SHA-256 algorithm. The header is base64 URL encoded to form the first part of the JWT. The second part of the token is the payload, which contains the claims. Claims in JSON Web Tokens are statements about an entity, often the user, and include relevant data. They are categorized into three types: registered claims, predefined claims like issuer, ISS, expiration, XP, subject, sub, and audience odd that are optional but recommended for standardization and interoperability. Public claims, custom claims that can be defined freely but should use collision-resistant namespaces or being registered with a IANA JWT registry. Private claims, user-defined claims for exchanging information between specific parties that aren't part of registered or public claims. The payload is then base64 URL encoded to form the second part of the JSON Web Token. There are a couple of things to note about JWT payload. The claim names are pretty short, usually only 3 characters long, as JWT is meant to be compact. JWT tokens are usually sent in HTTP headers. Some servers don't accept more than 8 KB of data in the headers. Although signed, payload information is visible to everyone. You can simply base64 decode the payload. Therefore, do not put secret information in the payload or header elements of JWT unless it is encrypted. The final part of the token is the signature. To generate the signature portion of a JSON Web Token, combine the encoded header, the encoded payload, a secret key, and the algorithm specified in the header. Then sign this data using the selected algorithm. In the example, the signature is created using the HMAC SHA-256 algorithm. The signature ensures that the token's contents haven't been altered during transmission. For tokens signed with a private key, it also confirms the authenticity of the sender, verifying they are who they claim to be. Let's take a look at some examples of JSON Web Tokens. Let's visit the website jwt.io. Here we see an example of a simple token. The token's header specifies that it is a JWT type signed using the HS256 algorithm, a symmetric encryption method. This means that the server validating the token must use the same secret key that was used to generate it. The token's payload contains claims such as sub, commonly representing the user's ID, name, and IAT, issued at, in seconds. This demonstrates how JWT encodes relevant data securely and compactly. Now let's paste in a token issued by Auth0 authentication server. This token has more information. This is a token encrypted with RS-256 algorithm. This is an asymmetric algorithm. The header also contains a key ID, a unique identifier for the cryptographic key used to sign the token. It helps the server locate the correct key to verify the token's signature. The payload has more claims. ISS, issuer, an entity that created and signed the token. AUD, audience, who or what this token is for. EXP, expiration time. Scope, the permissions or access levels granted to the bearer of the token. And AZP, authorized party, the party to which this token is issued. Now that you've seen the examples of JWTs, let's learn how JWT works. Although JSON Web Tokens are not used for authentication, there is still an authentication process at play when using JWT tokens. During the authentication process, the user logs into authentication server using their credentials. This server can be Auth0, Cognito, Firebase, etc. The authentication server returns a JSON Web Token. Since the tokens are credentials, you must take great care of them, preventing security issues. You should not keep tokens longer than required. Authentication servers typically issue JWTs with a validity period of no more than 24 hours. When a user wants to access a protected route or resource, the client application should send the JWT. JWT is usually sent in authorization header using bearer schema. The term bearer implies that the user presenting the token, the bearer, has authorization to access a specific resource or service. The server's protected routes will check for a valid JWT in the authorization header, and if it is present and the token is valid, the user will be allowed to access protected resources. When using JWT tokens, you should opt for a secure algorithm such as RS-256, RSA signature with a SHA-256, or ES-256, ecliptic curve signature with a SHA-256. Both algorithms rely on asymmetric cryptography using a private key to sign the token and a public key to verify it. For symmetric signing, HS-256, HMAC with a SHA-256 is also commonly used, but requires securely sharing the secret key. You should always use a secure transfer protocol HTTPS and avoid storing sensitive data in the payload of the token because it can be easily decoded. Because JWT is regulated by RFC 7519 and is scalable, stateless, and flexible, it is used for such things as authorization, information exchange, access delegation, for example OAuth, and session management in distributed systems. JWTs are a powerful tool for securing APIs. Let's learn how to use it in your project to protect the resources and authorize user access in the next video.